Okay, so let us start. So we'll solve some problems based on Serret and Frenet formulae. Just note down this. Got it? So we have the Serret and Frenet formulae. dt by ds is equal to kn and dB by ds is equal to minus tau n, right? So these are the Serret and Frenet formulae, and actually usually what he will be asking is he will ask us to find out the value of k and tau, right? There is one more Serret and Frenet formulae, but that actually just to know that tau b minus kt, so that is dn by ds is equal to tau b minus kt. So these are the three different Serret and Frenet formulae. But in the exam, what he is going to ask is, so he will be asking us to find out the value of k and tau. Got it? Or actually, he will be asking us to find out the radius of curvature and the radius of the torsion. So radius of curvature is 1 by k and radius of torsion is 1 by tau, right? Yeah. So this is how actually, so he will be asking the questions. In that, note down one problem. Find the curvature and torsion of the curve. Find the curvature and torsion of the curve. Curvature and torsion of the curve. X is equal to a cos t, y is equal to a sin t. X is equal to a cos t, y is equal to a sin t, and z is equal to bt, and z is equal to bt. Now this is as if like a cylinder, right? So here actually this parametric form of the equation is nothing but a helical shape. Helical shape we mean, so it will be started like this and then it will be cut like a spring, like this in a cylinder. Got it? So this curve equation is so given by these coordinates. So these coordinates are nothing but the parametric form of the point. Got it? So at any random point, if you find out that is at t is equal to some constant value, if you put it here in that, so x a sin t, so x is equal to a cos t, y is equal to a sin t, and z is equal to bt, will trace this particular curve, right? So this is a special curve, so which we call as the helical shape. So for that actually he asked us to find out the radius of curvature and the radius of torsion, or the curvature and torsion value, which are nothing but k value and tau value, right? So how do we find out this? We know only x, y and z locations at any point, right? So as I have given yesterday, that is ds by dt value is nothing but dr by dt mod, right? So based on this equation, ds is equal to, so dr by dt mod into dt. So if you integrate on either sides, so s is going to be, so integral modulus of dr by dt into dt, where r is given by a cos t into I plus a sin t into j plus bt into k. Got it? So this is the position vector. Suppose if you start from here, so at any random point, if you can take it, this is the position vector r given by at any time t by this equation. Got it? Understood or not? Now actually the modulus of this is, that is, so you can find out the modulus of this is, so a cos t whole square plus a sin t whole square plus b square under root, and then for that you need to integrate with respect to t. Now this value is going to be integral, this is a square into cos square t plus sin square t plus b square under root dt. So this is nothing but a square plus b square under root into dt. So this is a square b plus b square into t. So this is the value of s. Got it? So note down till this point. So this s value actually, if we start from the origin here, and then at any time t actually, if you want to find out the t value, so you can substitute even the limits also. So it will not make any difference. So this is the upper limit is t and lower limit is 0. Again it comes the same thing, a square plus b square times, so a square plus b square under root times t. Got it? This is the s value. Note down till this point. Then once you find out the s value, we can find out ds by dt value first. So s value is coming out to be, so s is equal to a square plus b square under root times t. So it implies ds by dt is equal to square root of a square plus b square. So this is the ds by dt value which we need to be finding out. Yesterday I explained, right? So we have to find out the s value, which is nothing but the perimeter at any point. So starting from t is equal to 0, this is traveling in this particular format. So at any time actually, if you want to find out, this is the value of s, right? S is nothing but the arc length, or in other words perimeter you can say, right, or the parameter, right? So arc length. So arc length actually s value is coming out to square root of a square plus b square into t, and ds by dt value is coming out to be ds by dt value. So that is equal to square root of a square plus b square. Now the tangent vector. So to find out, so k value you have to calculate dt by ds value, but actually the tangent value is nothing but dr by ds is nothing but the tangent, unit tangent vector. I have explained this in the previous class. Dr by ds value is going to give a unit tangent vector, because as t tending to 0, s will also tends to 0, and dr by ds leads to the same arc length for the same chord, right? So that is dr by ds value is coming out to be dr by dt divided by ds by dt. Why we have written in this particular format is r is a function of time. So given by the position vector r is equal to a cos t into I plus a sin t into j plus b times of t, so b times of t into k, right? So that is the position vector at any instant. Now r is a function of time and s is also a function of time, which we have derived this one. So from this dr by ds value we can find out by taking the derivative of r vector divided by derivative of s vector. Got it? So that is dr by dt is nothing but a cos t into I derivative. So derivative of cos is minus sin t into I plus, so derivative of sin is cos t into j plus b k, right? And then divided by square root of a square plus b square under root. So this value is nothing but dr by ds value, which is nothing but the tangent vector. Got it? So this tangent vector is coming out to be a sin t times divided by square root of a square plus b square into I plus a cos t divided by square root of a square plus b square under root times j plus b by square root of a square plus b square under root times k, right? So this is the tangent vector. Got it or not? Understood? Okay. So once you find out this value, if you want to find out the k value, then you can calculate dt by ds value. So this is dt by ds is equal to, so this is kn, which is equal to dt by dt divided by ds by dt, because both are functions of time. So t is again a function of time and s is a function of time. Then actually you can find out the derivative of this. This is ds by dt is square root of a square plus b square, and then the derivative of this is going to be, so a square plus b square, root will be cancelled because 2 times multiplication of the root, and then dt by dt is nothing but derivative of this is minus of derivative of sin t is a cos t into I. So derivative of cos is minus sin, then this is a sin t into j, and derivative of constant is 0. That is, so this is coming out to be, so a by square root of a square plus b square, and then minus, this is minus of a cos t into I, so a sin t into j. So a will go out, sin t into j. So this is getting multiplied by this a by square root of a by a square plus b square. Now this value, it is as if like this is equal to a by a square plus b square getting multiplied by minus this value is nothing but the n vector. Got it? So this is, I call this as k times of n, where k is equal to a by a square plus b square, and n is equal to minus a minus cos t minus sin t j. Got it? Understood or not? Any questions on this? So k value actually we have got. So that value is a by a square plus b square, and this value is nothing but the curvature. Here actually the procedure is simple. First actually you have to identify the value of the perimeter, which is nothing but the s. So s value at any time you identify it as a function of time and take the derivative of it. This is the standard procedure. Take the derivative of it. The derivative value is nothing but ds by dt, and then find out the value of t, which is nothing but the derivative of dr by ds, which is nothing but the unit tangent vector always. So that unit tangent vector is given by, so dr by ds, that value is again a function of time. Then based on the unit tangent vector, you again take the derivative, which is nothing but dt by ds, which will give the kn. So that kn value is nothing but the curvature into the normal vector. So n is minus cos t into I minus sin t into j. So that is the n vector. Got it? Understood or not? So from this actually we have got only the curvature. The torsion value also we should be finding it out. Noted down? Yeah. So now actually once you find out the curvature value, then the torsion value we can find it out. So if you want to find out the torsion value, torsion actually, so this is nothing but dB by ds is equal to minus tau n, where tau is the torsion. Now to find out the b vector first, so we have got the n vector. So t vector is this one, and the n vector is minus of cos t into I minus of sin t into j. So this is a normal vector. First you have to find out b is equal to t cross n, because as I given the order tangent, normal and binormal. So the cross product of this leads to the other one. All three are the unit vectors. Got it? All three are the unit vectors. So first we have to find out the normal vector. This is a square plus b square. So first we have to find out the binormal vector, which is nothing but I, j, k, and here minus a sin t divided by square root of a square plus b square, and then a cos t divided by square root of a square plus b square, and then b by square root of a square plus b square. and then at the last actually n vector is minus cos t minus sin t 0. So this determinant value we have to be finding it out. So this determinant value is nothing but b is equal to the binormal vector. So this binormal vector is b sin t minus b cos t plus a. B sin t into I minus b cos t into j plus a, okay, divided by a square plus b square under root. That's all. So this is the cross product. So you just need to do the cross product, AD minus BC. Similarly, AD minus BC. So for I, these two minus of this one minus j getting, so these two multiplications minus of these two products, and then k times of these two product minus these two product. So this leads to, so a sin t into I minus b cos t into j plus ak divided by square root of a square plus b square. This is what we have got as binormal vector. Now the derivative of the binormal vector with respect to s, that is db by ds value is equal to minus tau n. So once you got this binormal vector, which you have got by the cross product of two different normal vectors which are tangent and the normal vector. So this one is this one. Now for this you have to find out the derivative with respect to s. Then it will lead to the torsion value. Got it? Understood or not? Now can you take the torsion? Can you find out the torsion value and tell me? Anybody got the torsion value? By taking this vector b value, find out just dv by ds, that's all. So b by a square plus b square without root, Anubhav is correct. Yeah, that's correct. Right? So this is just take the derivative of that, that is db by ds is equal to again db by dt divided by ds by dt. So this is db by dt is the derivative of this with respect to t. So this is derivative of sin t is cos t, b cos t minus derivative of cos t is minus sin t. So this is b sin t divided by a square plus b square under root getting multiplied by again ds by dt is nothing but under root again. So this can be called as b by a square plus b square getting multiplied by cos t plus sin t. So this is I and this is j. So this is I and this is j, right? So this is the tau value. Clear? Any questions? Okay. So this is how actually you will be finding out the curvature and torsion values. Once you get these values, if you want to find out the radius of curvature and radius of torsion, then you have to take the inverse of that. So did you get a fair idea on Serret and Frenet formulae? Yes or no? Yeah, great. Fine. So this is about mostly what we have covered is the UPSC syllabus. Then some miscellaneous aspects also I am going to cover it. That is, he actually mentioned that there is something called vector equations. The vector equations are nothing but the straight line equation and the planar equation. Now these straight line and planar equations are just actually significance of negative before tau. So that is just the convention as I told you, right? So that is when we take, So when we take the convention, see this, we have concluded the direction of the tau in the form that is by taking that, so that is by taking the t vector and by taking the n vector, right? Then it was proved that, so the direction of, yeah, so I think so the direction of b vector is coming out to be, yeah, dB by ds value. We found it, right? So that is coming as minus value. So this minus value actually, it is leading to the negative direction. Here actually the fundamental assumption here it is, we have got a vector. The vector of n actually is decided based on the cross product, not because of just a rule, correct or not? It is just based on the cross product. Cross product can lead to a direction which is perpendicular to both the vectors, that is b cross n vector, sorry, b cross t vector. So b cross t vector is nothing but the n vector, right? So there actually when we prove that the n direction, right? So we have assumed that n is coming in one positive direction, but there actually it can be parallel is the appropriate answer than in the direction which is perpendicular to both these vectors. Got it or not? Perpendicular to both these vectors actually we have considered. So perpendicular to both these vectors, either in the positive direction, even in the negative direction also perpendicular to both, right? Correct or not? Arun? Understood or not? Now, if you take the perpendicular vector, that can go, so suppose if I take perpendicular to this board, then this can go in the positive direction or this can go in the opposite direction also. But as a convention, it was taken in the opposite direction. So that will be more appropriate direction for us. So that's the reason actually when we take the order of tangent, normal and binormal, right? So when we take that order, then actually we found that actually b cross t is equal to n and t cross n is equal to b. So this is the order actually we have taken. To satisfy that, actually we have assumed that the tau value in the negative direction, that is not for the magnitude, that is for the n. Got it or not? So yeah, so the vector equations are, so vector equation of a straight line. So this is actually one of the equation, maybe sometimes actually we are going to use. So vector equation. So one is the straight line equation of the vector. Another is plane equation of the vector. Does anybody aware of these equations? Does anybody aware? What is an vector equation of a straight line? Anybody? Okay, so this vector equation actually usually a straight line equation that is expressed in terms of vectors is called a vector equation, which is nothing but the position vector of the straight line at any point. Now this is more applicable for the 3D, so it will be more useful for a 3-dimensional vectors. Now suppose given a information saying that if the straight line is passing through a point and is parallel to a vector, then what is the vector equation of a straight line? So that is how actually the question is going to be asked. Now these values, let us say if it was given, this is x1, y1, z1 is the space point through which the straight line is passing through and it is parallel to certain direction. So let us say this is the straight line equation for which we want to find out the equation. No, I think so. Let me explain that. See this. Now actually this is the position with which actually this line is passing through. Now the position vector of this particular vector is this one. So this vector I call this as the A vector. So this A vector is x1 into I plus y1 into j plus z1 into k. So this is the position vector of the point through which the straight line is passing through. And the one more information what he is going to give it is the equation is the straight line is parallel to a certain vector. Now if it is parallel to a certain vector b, then let us say this is a vector b. Then the equation of this straight line is nothing but identifying a point on this particular straight line. So this position vector r, which will give xi plus yj plus zk. So this point, if you are able to identify uniquely on this line, then that is nothing but the equation of the straight line there. Got it? Yeah, right. So this is nothing but the line. Now in this equation, so this r value you have to identify it. Now if you want to identify the r value, then actually, so this is the r vector, right? So if it is r vector, then this line, so this is actually in the direction of b. Now if I just multiply b vector with some random value t, so this is nothing but the parameter or a constant. So this constant value is nothing but the length of this b vector, right? So let us say this is the b vector. So let us say this is the b vector. Then if you multiply this b vector with some constant t, then this will give the magnitude of b. So this is bt is nothing but if t value is more than 1, this will give you a value which is more than the b vector. If t value is less, which will be lesser than the b vector. If t value is 1, then it is going to be exactly equal to the b vector. Suppose if t value is negative, it is going to give you a vector which is in the opposite direction. Got it? Now at any point actually if you multiply a random number t to the vector b, then it will be adjusting the length of the b. Correct or not? Understood? So it will be adjusting the length of b. Now the length of b plus this particular vector. So this vector is e, right? So a plus bt. So this is the b vector, right? A plus bt will give this vector. So this is as per the triangular law of vector addition. As per the triangular law of vector addition, right? So the sum of this vector plus this vector will lead to this vector, right? Now this vector is nothing but a random position vector. This will be a random position vector just because of the parameter t. So a plus bt will always give you a random position on this particular line. So depending upon the t value varying from minus infinity to plus infinity, you will be able to identify any value on this particular straight line. Got it or not? Understood, Deepak? Yeah. So your answer is correct provided if t is equal to 1, right? So that will give only 1 point. But actually if you multiply with this parameter t, then actually it will extend your range from minus infinity to plus infinity for the entire range of this straight line. Got it? So this value, suppose if you want to identify this value, then just multiply this t vector, t value as a negative value. Let us say if you multiply minus 1 by 2, then this is going to be a minus b by 2. So this is going to be a point on this particular point. Suppose if you want to multiply with a value which is more than 1, then a plus 2b, let us say, then this is going to be a vector point at this particular point. Now at any instant actually this r vector will be representing the position of the point on the line. Got it? So this is the vector equation of a straight line which you have got from a simple understanding of the triangular law of vector addition by introducing a variable parameter. Got it? Understood? Or do you have any questions on this? Any questions? Exactly in the similar manner, vector equation of a plane. So does anybody aware of what is a vector equation of a plane? What is the vector equation of a plane? Having same normal or any other way? We need the position vector on that plane, right? So you should be able to identify from that equation any point of the plane. Now let us say this is a plane. Now this is a plane. Now actually on this plane actually you wanted to identify a random position. Let us say this is the origin. Now from this origin, let us say this is at a height of P. Let us say this is the height of P. And let us assume a unit normal vector. So this is n cap. So I have drawn a unit normal vector to the plane. Just imagine in your room, wherever you are there, just imagine the ceiling as one of the plane. Now for that plane, if you draw any line from the left bottom corner of the room, which we call as the origin, just draw a line to the location where the fan is hanging there, right? So the starting point of the fan, which is hanging there. So if you just join from the origin, that point is nothing but a point on the plane where you have drawn a position vector from the origin, that is left bottom 0, 0, 0, right? So that point is nothing but one point on the plane. Exactly in the similar manner, you should be able to identify every point on the ceiling. So I think there is a better way of expressing that, Deepak. So this is a unit normal vector. This is a length P. Exactly in the similar manner, the way we have derived them with the help of triangular law of vector addition in case of straight line. Even here also you will be able to find out with the help of the straight line, with the help of the triangular law of vector addition. Now actually, let us say this is the point where the fan is hanging. Now if I draw a straight line like this, this value is nothing but the variable position vector. This is the xi plus yj plus zk. Now this value I should be able to identify. Now if I wanted to identify that particular point, then this magnitude is P, which is nothing but the height till the ceiling, and this is the unit normal vector n cap. Then if you draw a vector like this, that is r minus, so this vector I call as P n cap is the vector P, right? P n cap, P is the magnitude and n cap is the direction of the unit normal vector to the ceiling. Now this is the position vector r. Now this vector is nothing but the difference of these two, that is, so minus P plus R. So this is the vector, I call this as B. So B vector is minus P plus R. So minus P vector, which is nothing but triangular law of vector addition. So this is triangular law of vector addition. If you want to identify this vector, then minus B plus R, which is nothing but this B vector. Now, what is the dot product of these two vectors? That is the dot product of, so that is P vector and R minus P vector. So the dot product of these two will be how much? What is the dot product of R minus P and P vector? It should be 0, obviously, right? So why it is 0 is, just imagine that left bottom corner as the origin and then draw the height h till the ceiling, that is nothing but the pole of the left bottom corner, which is z axis, and then we have identified one point which is nothing but the ceiling of the fan. Now from that fan ceiling, draw a line on the ceiling till the z, where this z is started from the origin as a straight line like this. Now that vector is nothing but which is drawn on the ceiling is the B vector, and this vertical vector is the P vector. Now B vector actually we have got from this particular vector as per the triangular law of vector addition, minus P plus R is equal to this vector, because as per the triangular law of vector addition, the dot product of these two is nothing but the ceiling and this z axis is having an angle of 90 degrees. That means the dot product will be 0. I hope everybody understood this. Got it or not? Now this value P dot R minus P bar dot P bar equal to 0, or P bar dot R is equal to P bar dot P bar. So this is the magnitude value P square, and this is P dot R is n cap dot R, n cap dot R. So this value is equal to 1 by P. So P will cancel. This is P. So n cap dot R is equal to P, which is the magnitude. Or otherwise you can call this as, yeah, so I think this is enough. Yeah. So this is the vector equation of a plane. Clear? Any questions on this? Any questions on this? So with this actually mostly we are done. Then actually, so in the next class actually I am going to deal with the spherical and cylindrical form of the del operator, and then maybe if possible I'll try to deal with some of the previous year questions so that we can conclude this topic altogether. So from 6th onwards actually Satya sir will be starting with the linear programming. Any questions you can let me know. See, don't worry about these things. Like actually those whoever is started late, maybe in December or January, right? For them actually it will continue. Like, so as in there is a serial order, that's what we are following, right? There is a serial order, that's what we are following. So everybody classes will be taken in a serial manner. So next topic is the real, so the programming, so that, yeah. Now don't worry about the expiry date. In case actually in time, if you are not able to, if we are not able to complete the syllabus, then actually we will extend it. Don't worry about it. Right? But actually I think so for everybody actually we have finished the syllabus on time without missing anybody. So usually it takes actually around 8 months to complete the syllabus.